This lesson is just a quick introduction to Scoop, the RDBMS import-export tool. We'll review the purpose of Scoop. We'll compare and contrast the Scoop and the Scoop 2 services. We'll look at some advanced Scoop usage, and we'll review some sample Scoop commands. First up, let's review what Scoop is. It's essentially to allow us to import and export data between a Hadoop cluster and an RDBMS database, like Oracle or MySQL. Scoop actually uses map-only jobs to select the data from the RDBMS in the case of the import, or insert the data into the RDBMS in the case of the export. The import and the export is from HDFS's perspective. So an import means pulling data from an RDBMS, and an export means pushing data back out to that RDBMS. By default, Scoop uses 4 mappers. This is configurable, but you want to be careful if you bump that number up too high. You could accidentally launch a denial of service attack against your database. You can also throttle the amount of bandwidth that Scoop can use in the cluster. There are many custom connectors available for Scoop for popular systems such as Netezza and Teradata, and Scoop was developed by Cloudera, as we saw with Flume. It's again open source and free. Here we see a layout of the Scoop service versus Scoop 2. With the Scoop service, we essentially need to install a fat client on our local machine. The Scoop service will then kick off map tasks in the cluster, which then dump data to HDFS, HBase, or Hive. Where it gets that data from is either an enterprise data warehouse or EDW, document-based systems, or relational databases. We can pull data from any of these systems via a map task into HDFS. We can also take HDFS data and export it back out to any of these systems. The Scoop 2 service is essentially a smaller, much more lightweight client that we install on each individual user's machine. The Scoop 2 service then exists in this middle layer, and it has a REST or web URL call mode, a simple UI that we can access via browser, several other connectors, and it also requires a metadata repository. This is typically the same metadata repository as Hive. Users then use this lightweight Scoop client to make calls into the heavy Scoop server and run their additional map tasks. We see here that it runs this exact same mode, except it may actually run reduced tasks as well. This centralized Scoop server means that we can lock down security and access to this server and only allow our users to download these lightweight clients or access via the browser. Scoop 2 is probably the preferred way to run Scoop these days. Let's look at some advanced usage examples. Scoop can support incremental updates, meaning all deltas since the last AutoInc or timestamp field update. We can also limit the import rows and or columns via select, where, and limit clauses. As with Hive, we see heavy MySQL influence here. Scoop can also autogen Hive metastore tables and can put data directly into HBase. We can directly import delimited text like CSV or other systems like TSV, or we can use binary systems like Avro and sequence files. Scoop supports large objects such as binary large objects or blobs and character large objects or clobs. And it also has commands for database inspection, doing things like showing, listing, and so forth. Let's zoom in on a few syntax examples. Here at the top, we see the basic way that Scoop is run. We simply call Scoop, passing it an import or an export command, specify a username and a password. In this case, we'll be prompted for password, and a database connection string. Here we're just using standard JDBC, which means after we list the host name, we simply call / and then the database. We can also specify an option file for credentials and imports. This is especially useful to hide connection strings and to make our Scoop command shorter. Here, let's say that we want to import the orders table from a live database, and our credentials aren't stored in creds.txt. We simply run this command scoop import, passing it the options file. Again, this is a file on our local machine where we're running Scoop, the connection string to the live database on the database server, and specifying that we want to import the entire table orders. Let's say that in a dataset we only want to import the deltas since the last time we ran Scoop. In this case, we can use the last value command. Here we're specifying a Scoop import with the same options file, and this time we're adding the connection string as well. We're importing the orders table, but this time we issue a check column, and we're passing the ID field. We're saying that we want to add all the records since the last ID was 17092. This is a great way to import only the deltas since the last time that Scoop was run. We can also import deltas since a certain timestamp. Here, let's say that we only want to import certain fields. We're issuing again a scoop import, passing our options file, which is our credentials and connector. And this time we're issuing a query, and we're saying select only these fields from the employees table where it's the high value employees making over $100,000. Again, we said Scoop can export data back out, and here we see we simply replaced the import command with an export, and then an export directory of where we're pulling our data from. In this case, this is the user Hive warehouse recommendations updates directory, and we want to pump the data back into the recommendations table. Here, we're issuing a list command just to simply list all of the tables in our live database. We can also evaluate scripts before running them. In this case, we pass Scoop an eval command and specify with a -e what data we want to pull out of our database. This data then spits back out to the console, and we can easily use this to preview our queries to make sure that we're actually pulling in the right data. We can update an RDBMS based on the ID key, so that when we put records back into our RDBMS, any data that we have in Hadoop, in HDFS, that matches an ID field that we find in our RDBMS, we simply override those records. We can also use Scoop to import and create Hive tables. Here, simply by passing a Hive-import switch to our Scoop import command, we're allowing Scoop to create the Hive metastore tables, and it will grab the appropriate data types for each column. This was a quick introduction and overview to Scoop. We should now know the basic features that Scoop provides and be able to understand a few simple Scoop commands.